Okay, this chapter is going to start off with proving identities. That's right, we're doing proofs. Woohoo! We have here some basic identities that you already know. You just didn't know we called them identities. You know that sine is really 1 over cosecant, cosine is 1 over secant, and la 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 la. What we want to bring back are these puppies right here. These were your Pythagorean identities. And we got these off of our unit circle. So the most famous one we have is sine squared plus cosine squared equals 1. But did you know that you can manipulate that? You can get 2 new identities out of that. Because you can subtract sine squared and put it on the other side. And now you have a new identity. Cosine squared is 1 minus sine squared. Likewise, you could use the cosine squared and move it over. And then you'd have sine squared is 1 minus cosine squared. And I'm able to manipulate that with my other 2 Pythagorean identities. And if you're sitting here going, wait, I know the first one, but I can't even remember where she got the other one from. Well, remember, this is a manipulation of the first one. How did I get 1? I divided by sine squared. If I divide that by sine squared, I have to divide everybody by sine squared. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent. And then 1 divided by sine squared would be cosecant squared. But that should be all review. So I don't want to waste my time with that. What I want to show you is all these manipulations. Ooh, can you hear the fire trucks in the background? Likewise, I could take this and I could move my cotangent squared to the other side. And I get a new identity. Cosecant squared minus cotangent squared gets me the number 1. And likewise, I could move the 1 to the other side. And cotangent squared is cosecant squared minus 1. And thus, I can manipulate my last one. So, on the next page, I have all these identities written down. I highly advise you to right now to stop this video and write these all down on a big separate piece of paper, because this separate piece of paper you're going to go back to and back to throughout this whole chapter. So make it a piece of paper you're able to pull out and look at, just like you used to do with the unit circle. So go ahead, stop, and write them all down. Okay, good. Now that you've gotten them written all down, notice how I set them up. I have my Pythagorean triples over here. And then right below I have the manipulation of each one. So this first Pythagorean triple can be manipulated twice, and so forth and so forth. So now, you see that big word on the side there, prove? So alright, what do these proofs look like? Well, back in geometry, you had over here a statement, and then you had a reason you could say that. And we had started off with our given. Well, we're not really doing that, but basically we're still going to look like a proof. This is what's going to happen. We're going to have this statement. We want to prove that one side equals the other side. So we want to prove this side can boil down to that side. And we're going to use our identities to do it. I want to manipulate this so that when I do a sine times a cosecant times a cosine, all that's left is a cosine. So, going to start off with nothing doing with that sine. I'm going to keep it sine. But see this cosecant? Every time I see a cosecant, I can replace it with a 1 over sine. And then I'm going to keep this cosine the same. Now you may be asking yourself, how do you know to do that? This is just a game of substitute, see what happens. If it doesn't work, try something else. And for most high school kids, they don't like to do that because that takes too much time. Sucks to be you, that's what you got to do here. When I multiply, I know that any numerator can cancel out with any denominator, and I'm leaving me with 1 times cosine. Alright, so I have cosine left, and voila, I proved this. See, originally we were asking, does the left side equal the right side? And then I just proved to you that the left side does indeed equal the right side. Proof 1 completed. Proof 2. Now you can work with either side of your proof. It does not matter which one you work with. See, right here, this cosine squared, well, I see up here that cosine squared, I could put in 1 minus sine squared. And then I'd have to manipulate 1 minus sine squared to come up to 1 minus sine over cosecant. And you can. It doesn't matter. But I'm just going to start with working with the left side and trying to turn it into the right side. Alright. Well, this 1 I'm going to still bring down as 1. There it is. Sine, I'm still going to bring down as sine. But instead, this cosecant, I'm going to bring down as 1 over sine. Alright, so now I got to manipulate. Well, the 1 is going to stay 1, and the minus, but aha, I remember when I divide, I flip the fraction and multiply. So sine times sine gets me sine squared. Aha, look up here. 1 minus sine squared, every time I see a 1 minus sine squared, I can really replace it with a cosine squared. And I've got it. I got a left side to equal the right side. Check. I proved it. Let's try another proof. I've got a lot of things I can do here. See this number 1? This number 1 shows up a lot. Over here, over here, over here, over here, over here, over here. So it's just a case of, well, which one do I want to play with? Well, I see a cosine squared, and I see a cosine squared over here. So I'm going to start manipulating this proof so I can somehow get that sine squared plus cosine squared. If I put a 1 under this, this is commanding me to add these fractions together. Alright, so to add fractions together, I have to get a common denominator, which is 1 plus sine theta. So I'll take sine theta over 1, I'll multiply it to get my common denominator. And this is where you have to really be good with your basic math. Alright, so the common denominator is 1 plus sine theta. And over here I get sine theta, because I'm going to distribute, plus sine squared theta, plus cosine squared theta. Boy, that's one big mess. But wait a second. sine squared plus cosine squared theta. Hey, look there. Sine squared plus cosine squared theta equals 1. So I can replace all that, whoops, with the number 1. And then I have sine theta over 1 plus sine theta. And anything divided by itself is 1, which equals 1. Hey, so I proved another one. Not bad. Okay, last one. Once again, I kind of look over here, and I see that I've got a cotangent squared right here. So that's when I want to manipulate this left side so that somehow it looks like one of these. I'm going to start with the same thing. Let's see. If I could get a cosecant squared. Can I get a cosecant squared? Yeah. Because this sign right here, I'm going to replace with 1 over cosecant. Up top, I still have my cosecant. And then I have my rest of my problem, minus cotangent squared. I'm dividing here, so I know I flip my fraction and multiply. So that gets me cosecant squared theta minus cotangent squared theta. Ah, and I got that right over here. Every time I see a cosecant squared minus cotangent squared, I can replace it with a 1. And that indeed equals the 1 over here. Beautiful.